Hello everyone, I'm Paul and today we're solving problem 2410, maximum matching of players with trainers. This one is medium and there's simple logic we can use here, so this won't take long. We have two integer arrays here, one with players where each value represents the ability for each player, and the other array has trainers where each value here represents the training capacity of each trainer. Our job is to return the maximum number of matchings between players and trainers according to these conditions. We find a match if the training capacity of a trainer is greater or equal to the ability of a player. Let's say we're given this input. These are players and these are trainers. My first intuition here is we need to find the best possible matchings. What I mean is the following. For example, we can match this player with this trainer, but it's much more convenient to match this player with this trainer, because here the difference is 1, and if we match this player with this trainer, here the difference is 4. So here we are kind of wasting 3 points compared to this. So the question is, can we preprocess this so that we can use some pattern to get the best possible matchings? And the answer is yes. We can sort these arrays, and this is the key for this problem. Let's see why. So these arrays are now sorted, and now we can see everything more clearly. For example, we know that we should never use this trainer because this is smaller than the smallest player. So we will use these 3 trainers only. So this will be the entire approach. We'll iterate players with an I pointer and trainers with a j pointer. And we are checking if the trainer is greater or equal to the current player. In this case, it isn't, so we update the j pointer. Now we are comparing 5 and 4, and 5 is greater than 4, so we can add 1 to the result. So now the result is 1, and by the way, remember this is the perfect combination in this example. Remember what I said a few minutes ago. It's much better to match 5 and 4 than to match 8 and 4. So in this case 5 is greater than 4, so we update the I pointer and we update the j pointer. Remember, each time we update the I pointer or the j pointer, it's because we don't need previous players or trainers anymore. So now we are comparing 8 and 7. And 8 is greater than 7, so we can add 1 to the result. This is now 2. Finally, we are comparing 8 and 9, and 9 is greater than 8, so we update the j pointer. Now we reach the end here. We don't have any more trainers. We still have 1 player, but we don't have any more trainers, so we end this here and we return the result. Time complexity for this approach will be big O of n log n plus m log m, where n is the size of players and m is the size of trainers, and space complexity will be big O of n plus m. So now let's go with the code and hopefully you will get the idea. First we need to sort players and trainers, so players.sort and trainers.sort. Now we will say p equals the length of players, t equals length of trainers. We will set an I pointer to 0. This will be for players. The result is initially 0. We will return this result. And here in between we will use a j pointer for trainers. So for j in range t, remember our example, no matter what, we always update the shape pointer, meaning the pointer for trainers. And here, if trainers at shape is greater or equal to players at I, result plus equal 1, we update the I pointer in this case. And if after doing this the I pointer is out of bounds, meaning it's equal to P, we break the loop. And finally we return this. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.